Same,
good enough
yeah. I
because
just
I'm
try to stick to
right.
kind of.
So you may begin 5 seconds after I close the door.
okay.
Okay.
So then the countdown starts. When? Now.
No.
5, 4, 3, 2, 1.
Welcome this morning to that new podcast at the University of Medipol in Istanbul.
I'm so sorry. Could we begin again? Because we didn't know you were going to start.
Yes, he's going to start.
You will start.
He's
I'm
interviewing me, by the way.
sorry. Okay.
So just for information.
We'll do it like that.
Should I count down as well? Again?
No, you don't need to count that. You can
Okay.
just count down in your head.
All right.
Okay, okay.
I'll close the door, 5 seconds.
All right.
Sorry about that.
All good. Still 5, 4.
So, good morning, everybody listening to that podcast. We are conducting podcast today at the University of Medipol in Istanbul with Dr. Emre Eroglu. It's a pleasure today to introduce Emre from the University of Medipol here in Istanbul, and it's a great pleasure to host that interview with him. Dr. Eroglu has substantially contributed to the research in the field of redox biology. He is a specialist in investigating, studying, and developing sensors for various molecules involved in redox biology related to nitric oxide or NRF2 signaling. He has published substantially over the last few years, and he has built up his own research group here in Istanbul. During this podcast, I'd like to ask a few questions related to Emre's research career. I'd like then to discuss some of his major research findings where he thinks should be attention being drawn to. And finally, I'd like to find out from him how he sees his involvement in developing early research career scientists and how he sees his contributions to support the next generation of scientists. So let's start with the early days in your career, Emre. If you would like to give us a rough overview how you started your research and what were the main driving forces for you to get into biosciences.
All right. So Jörn, thank you very much for this really great introduction. Thank you very much for being here and my guest here in Istanbul at the Medipol University. And we are together here with Giovanni Mann, a long-term collaborator of mine and a mentor as well. So again, thank you very much to the both of you for coming and following my invitation. So coming to your question, at early days, how I went to science or how I became a scientist. You know my unconventional way and background. I left school with 15 and started a career as a carpenter, and obviously not really successful in that. At the age of 20 around, I realized that being a labor worker is not really what I was pursuing the rest of my life. I was thinking that I should do something using a little bit more my brain, but without knowing what's going to be. And when I was around 18 and 20 and around, I was planning to study medicine. That's what I started to pursue, and actually without having any plan how it's going to be and how I should become a doctor, because I was born in a little village and grew up in that village in Austria. But when time passes, I had realized that there are ways and opportunities how to get back to school after having skipped it. And the government had those days a good opportunity, which is called the University Entrance Exam, which I pursued and tried to do it. It was, as you can imagine, extremely hard because I was someone who did never read a book, had zero mathematics skills, no English knowledge and nothing. And it took me quite a long time to catch up. Actually, if I would ask me these days, very, very simple, basic lectures. It took me a few years to get to the point that I was ready and mature enough to enter the university, which was at 27. But because of other reasons, European Union changed some regulations those days in medical universities. I was unable to study medicine, and instead I decided to go for biology, without not knowing what I'm actually doing. Just, as an alternative to medicine, I just started with biology. That was 27, and that was the next big challenge because I didn't expect that it must be that it could be so hard in the first years. The first semester I got analytical chemistry, and chemistry for itself is already very hard, and then analytical chemistry, instrumental analytics, was one of the first classes I got, and it was like, getting from left and right, smashed on my face. And it took me literally 5.5 years to complete the bachelor's in biology. And during that process, I started learning how to learn. I didn't even know how to read a simple page of information from a book and to extract what is essential and important actually for me to pass the classes. So it was a process, it was a long process, and around 32 or so, I completed my bachelor's. And when I graduated, as probably most of the people when they graduate after bachelor's, they expect that everyone opens their doors and expect them to give them a job. So that was my expectation as well. What happened is they gave me a sheet of paper in my hand, this is your degree, and that's it. So I couldn't do anything with it. And I thought, okay, that's not going to work in that way. I need to continue, obviously, which I did. And I set the level even higher and started studying technical chemistry, which not many people are pursuing because it's hard and it's not really attractive to many people. While doing that, it was funny and hard, but I had already the skills to how to learn things and better understanding for science, and was also mature. My colleagues, I was 10 years older on average than most of my colleagues. It was hard but funny, but at the end, I realized that was approximately the time when I realized, science is when I understood what is science, what scientists actually are doing, and start thinking, maybe I should study science and not just complete the master's, get the diploma and get a good job, but science started attracting me without really knowing how to become a scientist or where to go. And I wanted to do the PhD at those days, but I was already above 30. And for whatever reason, our university in Vienna had a regulation: students who are above 30, they were not allowed, or at least not they were too old for a PhD program. And I was, of course, as you can imagine, extremely annoyed by that, and it was disappointing. And then I thought, what, I'm going to go back to medicine. I'm going to start studying medicine. I will restart everything from zero, which I did. I prepared for the entrance exam for medicine. I got a position in a place in Graz, Medical University of Graz, where I went and started studying medicine. First semester, it was easy cheesy. The students, 18, 19 years old, me, myself, 35 or around. It was also annoying because like kids, and I was like their big brother or almost their father like. The first 2 semesters were great, or easy actually. And simultaneously to that, I was completing my master's diploma, and I had to finish my thesis. And that was exactly the time where I the first time went undeliberately to science, namely the following way. I was looking for a laboratory where I could do my thesis. And, I like simple things. I like everything in the most simple form. I was screening different laboratories where people are looking for a position for a student who can do their thesis. And I found one lab where the title was Working with Fluorescent Proteins. Mm-hmm. It was as simple as that. And fascinated by this title, exactly this is what I want to do. I went to the office of the professor. It was Roland Malli, in Medical University of Graz, knocked his door. I would like to work with you. And he said, what skills do you have? I can do cloning, and I know how to work with fluorescent proteins from my former PhD studies. He said, okay, come, and let's work together. He gave me 2 papers. Read these papers, and let's have some fun. And that's the way how it started the first time when I dived into the field of science, without knowing anything about biosensors, without knowing anything what that is. My actual aim was finishing the thesis, continuing studying medicine. Yeah.
If I may just continue taking up on this one. So your career path is not a very traditional path.
No, it's not.
I guess, and you seem to have been very many bricks being put in the way, be it age or other factors which kind of hindered you almost a little bit
Right.
in pursuing your career. I also saw from your CV, which is in front of me here, that you moved to Boston, to Harvard Medical School
Right.
in 2017. What made you change from that very promising place in Graz,
Right.
where you just started taking up that
Right.
very exciting and interesting position? What made you change the lab or the focus of your research,
Right.
if it was?
So that was actually necessary to
Mhm.
go away, because after a certain time, when you are saturated in a lab, you have produced already lots of papers. That was in my case. I guess I had already 8 papers in a very short time after discovery of. We haven't talked about that. What happened afterwards when I joined the lab of my previous PI is that without having any plan what I'm doing, when I got the idea, okay, what I'm doing is actually not bad, but it's not so productive, I went again an unconventional way and did something that people wouldn't do in the design and development of a probe, which ultimately ended up in a very informative biosensor, which is a nitric oxide biosensor. You have to know that nitric oxide, it was discovered when I was born 42 years ago, and there are 180,000 papers published about nitric oxide, but none of them were able to measure nitric oxide in live cells. So that was suddenly possible with a little and very naive approach I used in the lab, because I love simplicity, and I made a very simple approach, and it worked out. So that technology was then later patented. It ended up in Nature Communications as a paper. But I still was a medical student and actually not a PhD student in this laboratory, until my PI told me, you forget about studying medicine, continue in science. And that was where I really dived into the field. So, and then of course I started the PhD program with zero English knowledge. That was very, very hard for me, because the entire environment was German. We talked German with everyone. The lectures were in German. And again, that was the next challenge, learning everything and being able to understand papers, etc. But somehow managed these things and published papers. But soon came the time when it was really time to go and move on and move forward. And what I did, I focused actually on only 2 or 3 laboratories, which are close to that what I'm doing. One of the laboratories was Giovanni Mann's lab in King's College London. Another one was anywhere in New York, which was close to developing of biosensors, RNA-based. And one of them was Thomas Michel in Harvard. I didn't even know that he's in Harvard. I just found his website. I saw, they're using hyperbiosensor, which is hydrogen peroxide. They are measuring nitric oxide with other biosensors, with chemical-based ones, and they are studying the relationship of these things. That attracted my attention, and then I applied for it. The application was actually email. And then the answer was, yes, please come to our lab and let's work together. And that was as simple as that, just quick back and forth. And then I found myself already writing a grant to go abroad, which was funded, luckily. And a year later, we moved to Boston. And just, a few days later, I realized it's Harvard, actually. So I didn't target any school or something like that. I just targeted a research environment, a laboratory where I can work and do my research that fits my skills. So that was actually the reason why I went there.
How did you find that strong transition from the European, Austrian background, coming from a Central European, German-speaking country, going to the United States, where the science system works very, very differently,
Yes.
language challenge, as you just mentioned.
Right.
How did you adapt? How did you find that challenge starting in a very different scientific world?
Actually, the transition was not really a challenge. It was more smooth, and it was like it was more funny, and I enjoyed it a lot, the transition. The beginning was good. I liked the new environment, the openness of people, the kindness of people. Over time, then frustration somehow came. After, I came from a laboratory where we had lots of technicians. Everything was regulated. Cell culture was made by technicians. People did orders for us, everything. The PIs wrote the papers, I don't know what else. Everything was somehow, we were in a protected environment. But then it was like, at the beginning it was fine when you just arrive and then you start growing the first colonies, etc. But then you realize, I have to do everything by myself. I have to order things. I have to plan the experiments by myself. I have to analyze them by myself. I have to write the paper even, which was, of course, a part of my training, and it was necessary, and absolutely necessary. And I'm very, very grateful that this happened. But, as you can imagine, these are new things, and then somehow ended up approximately a year later very much in a frustration, because when you do everything by yourself, that was the challenge, actually, because I was used to have help by others, and I love collaboration. I collaborated with my colleagues a lot, with my PhD fellows, with other PIs from other institutions back in Graz. In the States, that was a little bit different. You're more individual. So you are the one who is basically carrying all these things, and if you have a good PI, which I did, then you have the support from your PI, but not more than that.
In this case, do you think your scientific inputs into the new lab were acknowledged and rewarded in a way that you expected it, or in a way that you experienced it previously? Or would you say that you are putting in lots of efforts without getting much out as a result?
I would say the latter one. I would say it was rewarded, but in a different way, namely the following way. Other than in Europe, American people are, motivating and exaggerating often. When I gave a seminar the first time there, wow, this is great. Oh, this is cool. Like these kind of responses I got a lot. And that was the first time in my life that someone said, what I've done is great. Because in Europe, you say, nice, very dry and not so, and that I acknowledged a lot. And when I recognized, people like what I have done. Now, they haven't even touched anything. They just listen to what I've done. That was very motivating. And this was already a great reward for me, that people recognize what I'm doing. They find it well and nice. And of course, as I said, you are more an individual. And if you have a PI who is, an established researcher who does not need to prove anything to anyone anymore, then you get more support and mentorship, and they come and tap to your shoulder. Well done, even if you know that you haven't done anything.
Being recognized or acknowledged with your contributions and your outcomes is a great and motivational. Has a great motivational impact. You have received several awards and prizes. Looking at your CV again, which of them would you say would be the most important one for you, or the most deserved one in your eyes, for which you received it? Honestly,
to say that, if I'm not wrong, I got 12 international awards. Some of them given only once a year to the best diploma in Europe, in Austria, and these kind of things. I was so much focused in my research those days. This all I got in the last 4 years or so, 4 or 5 years. And I was so much focused that it was just getting these things was kind of, I go there and take it and go home and continue on the lab. Check box and then just continue my research and focus on my research back. I don't remember that I was excited once in one of these awards, and I never worked for it to get an award or something like that. It somehow came and I got it. I got from Turkey awards. I got recently from the Society for Free Radical Research Award, which I appreciate a lot, of course. I like it. But it does not trigger that motivation. It's not the motivation for me anymore, and I don't do that research to get these kind of awards. It's nice to be awarded. I see it more like from my own students as a a model that someone can, one of us can get such awards, and we should pursue that way as well. But when I think, I'm really trying hard to remember. Often I just took these sheets or these prizes and just went home with it without having any other. I didn't do it for that.
So many other rewarding feelings or experiences in our research careers are also publications, papers. So and you have a very high and consistent, strong output over the years. Since you essentially started your career, with every year having 5 to 6 publications. Which of them would you think is your most important, or the most where you're most proud of, and your kind of output or your recognition of the paper would be your top over the years?
I mean, here actually the same thing. I never made these things when I started in this field the first time. I was extremely motivated when I saw colonies on a plate. I was very motivated when I saw signals. I'm still doing the same. I go to the lab, the probe I've developed 7 years ago. When I see it works in a new cell line, I see the signals, it motivates me. I've never made anything of this for a paper because I didn't even know what a paper is, what a paper is good for. I learned just, believe it or not, 2 years ago what is an H index. I didn't care about an H index. People taught me that I have to have a good H index and these kind of things. Of course, I was happy and proud when I published the first time Nature Communications or when we submitted to Nature Methods and we were fighting with the reviewers. That motivates, of course, when you understand what it's good for. But, and we have other Nature Communication papers as well, like good papers in PNAS and Redox Biology, etc. And we are happy and we celebrate when we publish there, but we don't do it. This is not our aim. And, you know, we just continue, focus to do the best possible research we can. That's the only thing we pursue. And everything else, good papers, awards, students that that they turn hopefully into good early career researchers and get a good position at the university. That's the aim.
And that's one of the keywords I'd like to focus next as well, early career researchers and students. So you managed to establish a very successful and powerful research group here in Istanbul. How would you see yourself in your position now being able to support and to foster the next generation of students? What would you think is your main contribution helping these new guys? And how would you go ahead to also focus and support the most talented students?
Right. So this is a very hard question for which I don't have a general formula, a universal formula I could apply for this one, because then that generation is obviously completely different. Although the age difference between me and my students is not that much, the interests are completely different. They looking at the problem from their eyes is completely different, and it's hard. Don't forget, I just opened the lab 3 years ago. I'm still learning. The process I underwent the last 3 years from the beginning until now. I've learned a lot to deal with these people and to motivate them or lead them respectively that they can become good scientists. I think we are in a time that is different than the few years between us. Obviously is so different than the years between me and Giovanni, for example, right? So I can see similarities between a career that is 30 years ago and mine, but the few years between me and my students in relation, you know, is it the internet, is it the social media, is it the all these possibilities and capabilities they have, or chances they have and probably think that they are missing anything in their life? I don't know what it is, but it's different, definitely different.
Yes.
And I have the same problem with my children as well. You know, I have children 21, 20 years old, and there I see the same thing. You know, the needs we had as children is completely different than the priorities of them. How to lead these people to become good scientists? Honestly, very honestly, I'm still learning. I don't have a plan. I have a plan, but I don't have a formula I could tell you this is the way how to do it. I don't believe there is something like that. It's individual, and I think this is something that needs to be treated individually, because everyone is different.
Everybody's different. That's the main point, I think. Agreed. My research in neuroscience is also focusing on disease conditions. So I'm looking into different pathologies, Alzheimer's as an example. So how do you think can your research outputs or research goals meet the needs for investigating or studying neurodegeneration in our days?
Right.
Because these are pressing questions with our aging population and more people suffering from these age-related diseases. How can your research outputs contribute in a way to finding new treatments, applying new strategies?
So this is what I love to talk about, because this is exactly where we're at home. So we are developing tools, as you know, and we develop the tools in order to be able to see something in cells, animals, not only to see it, but also to be able to manipulate, disturb normal working signaling pathways. And often we are there where nothing exists yet, you know, and there is not even a research question yet there, but we develop something that makes a pathway visible in a cell or in a tissue that helps us the first time to understand how the mechanism works. And build on that, we can then ask questions. We are not even there to be able to ask a question, a scientific, hypothetical question, but we develop an approach or a technology, or we use existing technologies and bring them together to be able to ask new questions, although we don't even know it. So that's the beauty of our work. So we are at the very, very front, where there's, and even more I love it when there's really nothing, just a black box of which we don't even know how to approach it, and often good things happen in these things regularly. And as you can imagine, if you be able to ask a question because you now see, you have insight into a cell, now you see how that cell behaves, then you can ask your questions. But there, I try to force myself these years even more and more after having established my lab. I don't want to tackle these scientific questions by myself, but I would like to leave it to people who are experts in this field.
And that brings me almost already to the next question. I'm very interested in hearing from you the answer. So you're building up a very, very efficient research group here in Istanbul. Do you think you can address and tackle these questions predominantly here in your lab with your expertise and abilities, or do you think you need to involve other scientists across the world to become highly productive and find that application of interest?
Absolutely. Absolutely. We need to liaise with people around the world, which we do all the time. We have very great collaboration partners across Europe and in the USA. And without that, it wouldn't work. It would be just a tool we have developed. We would just be able, okay, here we have something, we can ask a question with that, which is for itself already cool, but it can be even more cool if we can make it useful for understanding physiology, understanding pathology, but that requires experts. I cannot be an expert of everything. I can, and we can, my lab can develop for almost everything a biosensor, but we cannot be an expert of everything. You know, we cannot study cancer, at the same time neurodegeneration, the same time nitric oxide signaling, the same time redox pathways. But all of these things, I have to tell you right now, for all of these things we have tools, and we develop tools for these fields, right?
And the development and the interaction with other fields is one of the reasons why I am here. And I would like to thank you at this time now for inviting myself and Giovanni to Istanbul. And I hope taking your words on growing networks and growing different perspectives and different labs together will help in developing our future relationships. And with that, I would like to thank you and finish the podcast again for your contributions, for your invitations, and looking forward to more successful outputs and work together with you.
Absolutely. Thank you very much for coming. Thank you very much for starting this collaboration with us. Thank you very much for being here in Istanbul. I hope you like it and enjoy the time here. And I also look forward to a fruitful collaboration in the future. Thank you again for coming.
Great. Thanks, Emre. Thank you.